Colligative. Okay, Patanjali, don't worry, I'll take that. See, solutions have different physical properties. Again, it can be classified into two categories for dilute solution and concentrated solutions. Okay, but it is very interesting thing is observed that there are four properties of a dilute solution which does not depend upon the nature of the solution. It may be anything, but it depends upon the amount of solute present in the solution. It's very interesting. Different substances are having different chemical behavior, but it is found that these four physical properties, they depend upon only on the amount of the substance present in the solution. And these properties are called colligative properties, means which they behave similar. Because of that, suppose we work in a place, people with whom we work, we do the same nature of work. For because of that, we use the word colleagues. Okay. So now we are going to write the definition of colleague. Those physical properties of dilute solutions containing non-volatile solutes which depend upon the number of solute particles. So it can be molecules or ions. Present in definite amount of solute. Or you can write present in the solution. Present in the solution. on their chemical nature of are called colligative there are two colligative relative varying in paper elevation in boiling point. Depletion in the osmotic
So I didn't understand the meaning of
what you could not understand.
so the meaning of colligative property.
Meaning of colligative property is not that you need not understand the meaning of colligative property. Here, these four properties of the dilute solution behave similarly. It does not depend upon the nature of this chemical nature of the solute, but it depends upon the number of particles of the solute. That is, suppose take the example of human society. Say there are four old women are there, four old males are there, four young girls are there, four young boys are there, four children are there. Okay, irrespective of their ages, if their behavior is same, then we can say that it is a colligative property. Here also, when I make a dilute solution containing non-volatile solute, okay, that is, they should not evaporate. So there are different types of physical properties is shown by dilute solution, even by concentrated. But it is found these four properties which we have found, it does not depend upon the chemical nature, not on their chemical nature of the solute, but depends upon what? Depends upon the number of solute particles present in the solution. So I can take any molecule of any property, but if they are present 10 numbers in the solution, okay, all of them will show the same property. Say I have made 10 different solutions. Some I made with glucose, some I have made with sugar, some I have made with fructose, some I have made with urea. Okay, so these are the substances which do not dissociate in water, but all the substances are different. If I measure their boiling point, you will find there will be a decrease in the boiling point. All of this will be same. All of them will show osmotic, same osmotic pressure. This is the called colligative property. So here colligative property means those physical properties of a dilute solution which depends upon the number of particles present in the solution and not on their chemical nature. We will call them as colligative properties. So colligative, there are 4 colligative properties are there. That is called the relative lowering in vapor pressure, elevation in boiling point, depression in freezing point, and osmotic pressure. I'm going to explain all of them one by one. Relative lowering in vapor. See, this I've already explained to you. Don't try to understand. This is a beaker containing water, pure water. And this is a beaker containing water and we know boiling point of this one is 100 degrees Celsius. Okay. So if you boil this having the same volume, if you boil this sugar solution, you will find this solution is not boiling at 100 degrees Celsius. It requires more heat. So the boiling point will cross 100 degrees Celsius. Now what is boiling point? You don't write. It is the temperature at which the vapor pressure of liquid becomes equal to the atmospheric pressure. That is, when you heat this water, when this vapor pressure of water becomes, see, when the vapor pressure of water becomes 760 millimeter of mercury, then only the water is going to boil. Okay, water is going to boil. Otherwise, it is not going to boil. But then at 100 degrees Celsius, that is at 100 degrees Celsius. Then why this is not boiling? In this case also we have heated the water to 100 degrees Celsius. Then why is it not boiling? Because I have already told you the vapor pressure of the water containing non-volatile solute is less than the vapor pressure of pure solvent water. the vapor pressure of solution is less than the vapor pressure of pure solvent. Why I told you that also? See here, I told you if you look from top, if these are the molecules at the surface, see in case of pure solvent, all the molecules belong to the solvent only. So the entire surface take part in evaporation. So in that case, what happens? It creates more vapor, and because of that, it becomes equal to the atmospheric pressure. Okay, so this becomes what? This is the vapor pressure, and that is becomes to the 1 atmospheric pressure. But when you have taken the solution is a homogeneous mixture. So in every place you will find the solute molecules are present. See, now in this case, what you will find? In this case, you will find that lot of the spaces now are being occupied by the non-volatile solute, which does not go to the vapor state. So the surface area for evaporation has decreased, so vapor pressure also decreases. As simple as that. But we want it should boil. So what we have to do? We have to generate more vapor. So you can generate more vapor from where? From those places where water molecules are there. This black one will not going to give you any vapor. So to generate more vapor, you have to heat it more. And when you heat it more, then only vapor pressure becomes equal to the atmospheric pressure. So what happens now? What do you say here? Relative lowering in vapor pressure. That is at 100 degrees Celsius. This is 760 millimeter, but in this case, vapor pressure is less than 760 millimeter. All right. So that difference is known as relative lowering in vapor pressure. All right. Understood? Huh? Hello.
Yes, sir.
Yes, sir.
So we'll write in a dilute solution containing non-volatile solute. In a dilute solution containing non-volatile solute, vapor pressure of the solution is less than the vapor pressure of the your solvent. This is the one that you have already done. Okay, moreover, as the non-volatile solutes do not produce vapor. So the vapor pressure of the solution is entirely due to the solvent. So whatever vapor that you generated is only because of solvent, because solute is not participating in vapor. Okay. So let me write down. Let a dilute solution has PSD vapor. Okay. You have that. The dilute solution is made up of solvent A and non-volatile solute B. Having chi A and chi B as their mole fraction. Let P be the vapor pressure of the solution and PA0 is the vapor pressure of pure solvent. Because it is because of solvent only. That PA is the vapor pressure of solvent. We are not mentioning about the pure. This is the pure. In a dilute solution containing whatever you don't understand, immediately you tell me. In a dilute solution but non-volatile solute, the vapor pressure of the solution is equal to the vapor pressure of solvent. Say now in the lockdown, you sometimes you help your mother also, is it not? Hmm? So whatever the work is there at home, your mother and you, both of you do. Maybe some region mother, she has gone to some other place, and she told you she will come in the evening because there is an emergency outside. In that case, Monday, there are two persons are there who is working at home. You and your mother. She is not there. So the entire work has to be done by you. So here what is there? Solute is non-volatile, is not producing any vapor. In that case, what will happen? In this case, vapor pressure of the solution is what? That we earlier assume like this. Equal to the vapor pressure of the solvent is what? P. So therefore, what we can write? P is equal to, right. Next step, I'll just tell, do, and you'll understand and write. So it is not a dictation class.
So what is written after solution? P, pressure of the solution.
In a dilute solution containing non-volatile solute, the vapor pressure of the solution P is equal to the vapor pressure of the solvent. Solvent we always consider, no, it will be as per your book. I'm following that symbol which is being used in your book. PA, subscript A. Okay. So now you know, actually, if you go by the volatile solute, then it should be PA plus PB, but here PB is 0, so it is P. Now, according to Raoult's law that you know, according to Raoult's law, what do you know? We know that partial vapor pressure is equal to the product of vapor pressure of the pure component and its mole fraction. Is it not? That we know. We have done only previous day. So it is 1. Okay. So let me write. Or I don't know how it is being done in your book. So I can write PA is equal to PA0 is equal to chi. Okay. So let me write this is 2. See, it is a binary solution. Binary solution means it has 2 components. Means it has a solvent and only one solute. Solvent is A and the solute is B. And what is this mole fraction? Chi A and chi B. I told you that sum of the mole fractions of all the components of the solution is equal to 1. Okay. So right, it is a binary dilute Hence, chi A plus chi B is equal to 1. Now you know it is the mole fraction of solvent and it is the mole fraction of solute. Okay. Then after that I can write or chi A is equal to 1 minus chi A. Then I'll write, sorry, so right now, substituting the value of chi A in equation 2, we get, what do you get? PA by PA0 is equal to 1 minus chi B. So now I can write. Okay. So I will transfer it to this side. What I can write now here? Or 1 minus PA by PA0 equal to chi B. You can write. Can I write or not?
Yes, sir.
Transfer this to the right hand side and left hand side. I'll bring in right hand side. I can write now. Hello, do you agree?
Yes, sir.
Okay, then see here, I'll take LCM. What will come now here? PA0, PA divided by PA0 will be chi. So now we can write, we know vapor pressure of pure solvent. What is this? PA0 is always more than partial vapor pressure of solvent. I already showed you, because when you take pure solvent, entire surface is having solvent molecules. So you generate more vapor. When you've taken the solutions, you'll find many places solute molecules are there. So from these places, the solvent does not come out to the vapor pressure decreases. Okay, so please remember PA. This is what we can write. Therefore, PA0 is greater than PA. I have written, and this is simple. So if I write here PA0 minus PA means what? It is a positive quantity. This is more, this is less. So what we can write? Or delta P divided by PA0 equal to IB. So what is delta P? Delta P is equal to PA0 minus PA. What should we call it? We call it lowering in vapor pressure. Okay. Now what is this? Delta P by PA0, what should we call it? Please remember, it is a comparison. Means it is a ratio. See, suppose in your first unit test, you have got out of 70, you have got first unit test, you got 50. Second unit test, you got 30. But your friend in first unit test, he got 65. Second unit test, it is 68. See here. So you will be compared, first you will compare yourself with your previous performance. But if you compare with your friend's performance, you will find you have done very bad because it's a ratio. So delta P by PA0 is called relative lowering because it is in comparison. So we will call it PA0 is equal to relative lowering in vapor pressure. Okay, now what is chi B? Chi B is what? Chi B is the mole fraction of non-volatile. This is very interesting. Now you find relative lowering in vapor pressure does not depend upon the solvent. It depends upon the mole fraction of the solute. That is how much solute you have added. If you added more solute, it will decrease more because it is directly proportional. Relative lowering. See, this is lowering in vapor pressure is on the numerator. So this is directly proportional. So because of that, we call it a colligative property. So what did you find? That the relative lowering in vapor pressure is equal to the mole fraction of the non-volatile solute. So now we are going to write the famous word in sentence. Thus, the relative lowering in vapor pressure of a dilute solution containing non-volatile solute is equal to the mole fraction of solute. In exam, you'll be asked to prove it. So you do all these things, come up to this. After that, you write this. See. So now we know delta P by PA0 into chi. ठीक है से? Now, how to find chi B? See, let the dilute solution is made of Na moles of solvent and N and B moles of non-volatile solid. Okay, dear. What is chi B? We know mole fraction is nothing but the ratio of that component, number of moles of that component by total number of moles present in the solution. What should I write now here? It will be NB and Na plus. So this is chi B. See, in a dilute, what is a dilute solution? Where you have added very less. Okay. Okay. Then I'll give you an example. Suppose in 1 liter of water. 1 liter of water means density of water is 1 gram per ml almost. So I have taken here 1 liter, 1 kg of water. Okay, means don't write 100 gram of. There I have added say 5 gram of sugar. Okay, molar mass of sugar. Sugar, I think C12, H22, O11. You will know, none of you will write. Is 340 gram. Means 340 gram is equal to 1 mole. So 5 gram is how much? So mole of sugar. See here. 5 divided by 340. Gitanjali, tell me this value. 5 divided by 340. How much it comes?
1/68.
I want in decimal. Take out the calculator. Lazy girl.
0.0147.
0 point how much?
0147. 0.0147.
147. Okay. So this much more. So dear, see here. 100 gram of water is equal to, you know how much? 55.55 more. Okay. So I'm making here KID. Don't write. So it is 0.014. Okay, I'll make it equal to what? 1 divided by 55.55 and 0.15. So it comes to how much? 0.015 divided by 55.56. All right. See, in that case, what is going to happen? Whatever the value we'll get, is it not almost same if we ignore this value? Is it not same? Value will be same or not? See, this is the by rule I'm taking it. But I found if I divide the NB by NA, whatever the value I'll get will be same as that value I'm going to get if it is NB divided by NA plus NB. Is it not? So in that dilute solution, I can ignore this one. All right. So this is my main purpose of showing all this. So I'll write now here because you may think that sir is writing and all rubbish, and she's telling us to believe. Why should you believe? Okay. In a dilute solution, there you write. You see here what I write. Na is much larger than Nb. Therefore, Na plus Nb is almost equal to Na. I have shown you just now. Na was 55.55 and Na plus Nb became 55.56. Same only. So I can write that in a dilute solution, Na is much larger than Nb. So I can write here now Na plus Nb. All right. So this was equation 4. No? So what we can write? Thus, equation 4 can be written as delta P by PA0 is equal to NB plus NA. Of the substance divided by molar mass of the substance. Okay. So now what is now NB? NB is mass of solute divided by molar mass of solute. See, solute is less, na? So in that case, I'm going to put small w. Okay, and for B, I'll write WB. And here M. All right. So this is the moles of solute. Okay, I'll write. I don't trust you people. You people are dangerous. More dangerous than terrorists. See here. Moles of solute. So NP is equal to what? Mass of solute divided by molar mass of. So what should I write now? Symbol will be what? WB by M. M is the molar mass, W is the molar mass. Then moles of solvent. What is the symbol? N. So what is this? Mass of solvent divided by molar mass of solvent. So WA divided by MA. One thing I forgot to write to there. There I have to put equation number 5. No, hey, last one you have put no delta P by PA 0 is equal to NB by NA. Put equation number 5. I forgot. Oh, this is the one. And it is there in front of me only. Okay. So what will write now here? Substituting the values of N A and NB in equation 5. Okay, what do we get? I'll write now here. Delta P by PA 0. See, write WB by MB. Yeah, WA by. So this is the denominator, it will come down. No, I will not write like this. I told you, no, you are unique species. I will write like this. WB MB. WA. See here. This will come down and this will go up. Therefore, I will write delta P by P0 equal to WB NA and WA. This is the third equation. This equation, see, it is confusing, no? W numerator also you have WM and denominator also you have WM. Huh? So how to see here? How to remember? Is it confusing? or you can remember? Hmm? Hello. What about others? It's not that I'm only calling Gitanjali. Gitanjali, don't feel that sir has some special liking for this lady. No, this is the only name which I can remember. Hmm. Of course, some more name I can remember. Also. Solve it. See, I'm a man with a very small memory. Okay. I cannot remember. And with this age, so I'm forgetting like anything. So I have to find my own way. Na? So delta P by this I know. Okay. Then WMW. So I write like this. Oh, this also I'll write. This also I'll write. Oh, W woman. Woman. Then who is on the top? This one. And this is at the bottom. Okay, that is. So if you consider the height, this is the one. This is one. And you know the top. See here. This. So this one is the top. And this is at the bottom. So she is in nursery. She's learning now A, B, C, D like this. He has already graduated. Graduated means what? BA. See, BA. And what is this? AB. Huh? So this is the way. So it is BA. And this is A, B, C, D like this. A for apple, B for ball. Hmm? This is the one. This is the one. So try to remember like this. So here again I'm going to write it this way. So this is our secret. Huh? This is the way to remember. See here. This is the weight of, this is the mass of what? Solute. This is the molar mass of solute. This is the mass of solvent. And this is the molar mass of solvent. See, when I make a solution, a molar solution, MOLAL, molar solution, the strength of the molar solution depends upon how much solute we added. But in all the cases, the solvent is 1 kg. It says number of solutes present per kg of the solvent. So this is fixed. WA is fixed. So what should I write now here? This one I'll put 6. In equation 6, all the factors on the right hand side of a molar solution except mass, sorry, except mass of solute. It is WB are constants. So right here, all the factors. What are those factors? It is MA, MB, and MA. Therefore, the relative varying in vapor pressure of a dilute solution containing non-volatile solute is directly proportional to mass of the solute or number of particles of solute. I'm writing this on for a reason. Okay. Hence, see what does the colligative property says? Those property which depends upon the number of particles of solute present in the solution is a colligative property. Now we have proved. Hence, depression in lower. Hence, lowering in vapor pressure of a dilute solution is a colligative. What did you find here? Delta P by PA0 is directly proportional to W because others are constant. I've already written. Relative lowering in vapor pressure of a solution is a colligative property. So from you write this equation, after that you write finish. Determination of molecular mass of solute. Determination of molecular mass of solute. See what is it? What is the equation number? This I'll write down again here. Delta P by PA0 is equal to WB MA and WA. This is the molecular mass of solute. So I'll just go for this cross multiplication. I'll write here now. MB is equal to WB MA divided by MA delta P by P. This is the one. That's all. Or what we can write? I'll put this on the top. MB is equal to WB MA PA0 by WA delta cross. Okay, now what is delta P? Delta P is PA minus PA0 minus PA. I can write one step further. MB is equal to WB into MA into delta P divided by WA into PA0 is the vapor pressure of the solution, the vapor pressure of the pure solid. I don't know. I think I'm going a little slow. I have to speed up. To do is takes little more time because if you don't understand, then my all my